In this video, we're going to talk about properties of logarithms. There are three properties: product property, quotient property, and power property. If b, the base, and x and y are positive real numbers, such that b is not equal to 1, and p is a real number, then the following statements are true. First, the product property. It says that log base b of x times y is equal to log of base b x plus log of b of y. And the quotient property says that log base b of x divided by y is the same thing as log of base b of x minus log of base b of y. Now finally, the power property says log base b of x to the power of p is equal to p times log of base b of x. Now, if you want to know the proof why these three properties work, I have made a video, so please look at the video that I made before this. So if you, let's say you have log of base 5 of 20. So using the product property, this is the same thing as log of base 5, 4 plus log of base 5 of 5. Because 5 times 4 is 20. And also, check this out, log base 5 of 5, this becomes 1. So you end up getting log of base 5 of 4 plus 1. If you have log base 7 of 2 over 5, using the quotient property, this will be log of base 7 of 2 minus log of base 7 of 5. When you have log base 3 of 16, you can rewrite this as log base 3 of 4 square. Now using the power property, this represents p. So this exponent over here could go in front of log. So we get 2 log base 3 of 4. But check this out. What about 4? You could rewrite it as 2 square, right? Again, that power 2 can go in front of it, and 2 times 2 is going to be 4. So it will be log, 4 times log base 3 of 2. So this is same thing as log base 3 of 16. Now, this property applies to natural log as well. So let's say you got natural log of x, y. Then that's going to be equal to natural log of x plus natural log of y. This is a product property of natural log. And then if you have a natural log of x over y, that's going to be the same thing as natural log of x minus natural log of y. And if you have a natural log of x to the power of p, using the power property, is going to be p times natural log of x. Now, this property applies to natural log because if you think about it, natural log is just log with base e. The common mistake that I see among students is that when you have, let's say, natural log of 20, right? And this is the same thing as natural log of 4 times 5. And they think this is natural log of 4 times natural log of 5. And this is not true. This is false. You could try it out with your calculator. See if, figure out what natural log of 20 with calculator. And use your calculator to multiply natural log of 4 times natural log of 5. You will notice that these two are not the same. So this is not true. Actually, this will be what? Natural log of 4 plus the natural log of 5. And you may confirm it with the calculator. Same thing with natural log of, let's say, 4 over 5. This is not natural log of 4 over natural log of 5. That's a common mistake. Actually, natural log of 4 over 5 will be, using the quotient property, it will be natural log of 4 minus natural log of 5. And you may confirm it with your calculator. It says express each logarithm in terms of natural log of 2 and natural log of 3. So basically we need to rewrite natural log of 54 in terms of natural log of 2 and natural log of 3. So let's break down 54. You're going to get natural log of 2 times 27. And 27 is 3 times 3 times 3, which is 3 to the third power. Now using the product property, this will be natural log of 2 plus natural log of 3 cubed. Now using the power property for this portion, you end up getting natural log of 2 plus 3 will go in front of natural log. You get 3 natural log of 3. So now we just rewrote natural log of 54 in terms of natural log of 2 and natural log of 3. What about natural log of 9 over 8? We have to rewrite it in terms of natural log of 2 and natural log of 3. So using the quotient property, this will be natural log of 9 minus natural log of 8. Now 9 can be rewritten as 3 squared, and 8 can be rewritten as 2 to the third. So we could apply the power property, and this becomes 2 natural log of 3 minus 3 natural log of 2. So we wrote natural log of 9 over 8 in terms of natural log of 3 and natural log of 2. We need to express each logarithm in terms of log of 5 and log of 3. Now notice this is a common logarithm. We don't see a base, so that means the base is 10. So let's break down log of 75. This is going to be log of 3 times 25. And 25 is 5 squared, so this is the same thing as log 3 times 5 squared. Using the product property, this is log 3 plus log 5 squared. And using the power property, this is log 3 plus 2 log of 5. So we just rewrote log base 5 in terms of log of 3 and log of 5. What if you have log of 5.4? I'm going to rewrite this as log of 54 over 10. And I want to reduce it. 2 goes into both of them, so you get log of 27 over 5. Now we're getting somewhere because we have to rewrite in terms of log of 5 and log of 3. So this is the same thing as log of 3 to the third over 5, which is, using the quotient property, log of 3 cubed minus log of 5. And using the power property, you get 3 log of 3 minus log of 5. And we're done. Let's evaluate this logarithm. You got log of base 4 of 5th root of 64. Let this whole thing go to y. Remember, log is our exponents. So 4 to the y equals 64 to the 1/5. You need the same base to compare the exponents. So this is going to be 4 to the y is 4 to the third to the 1/5, which is 4 to the y equals 4 to the 3/5. In order for this to be equal to each other, y has to equal to 3/5. Therefore, this whole thing is equal to 3/5. In order to evaluate this, notice natural log and e will cancel out because they're inverse. So you end up getting 5. Natural log and e cancels out, you get 2. 5 times 2 minus natural log and e cancels out, you just get 3. So it will be 10 minus 3, which is 7. We have to expand each expression. We got log of 12 x to the 5th y to the negative 2. So using the product property, notice these three are connected by multiplication. So we could rewrite this as log of 12 plus log of x to the 5th plus log of y to the negative 2. Now we're not done yet because we could still apply power property. So we get log of 12 plus 5 log of x minus 2 log of y. And we're done. We're done expanding. Now let's expand natural log of x squared over square root of 4x plus 1. Let's rewrite this as natural log of x squared over quantity 4x plus 1 to the 1/2. Now, using the quotient property, this becomes natural log of x squared minus natural log of quantity 4x plus 1 to the 1/2. Now applying the power property, you get 2 natural log of x minus 1/2 natural log of 4x plus 1. And we're done expanding. Now we're going to condense each expression. So we're going backward. This is expanded, so we have to condense it. So using the power property, we're going to rewrite this as log base 3 of x to the 4th power minus 1/3 will become the power. So log of base 3 of quantity x plus 6 to the 1/3. Now using the quotient property, it will be log of base 3 x to the 4th over quantity x plus 6 to the 1/3. Now this is the same thing as log base 3 x to the 4th over cube root of quantity x plus 6. And this is good enough. Let's condense this expression. So using the power property, we get natural log of quantity x minus 4 to the 6th power plus natural log of x to the 3rd power. Now using the product property, this will be natural log of quantity x minus 4 to the 6th times x to the 3rd, or simply natural log of x cubed quantity x minus 4 to the 6th. And finally, we're going to talk about change of base formula. When you have a log of base b of x, this will be the same thing as log of base of a of x over log of base of a of b. You need to make sure that a is not equal to 1 and b is not equal to 1. And a, b, and x are all positive real numbers. So let's say you have log of base 3 of 5. You could rewrite this as log of 5 over log of 3. Or this is the same thing, it's going to be the same thing as natural log of 5 over natural log of 3. Now natural log and log base 10 are the most commonly used logarithms. So we use common logarithm and natural logarithm. But you could also say that this is the same thing as log of base 7 of 5 over log of base 7 of 3 as well. But it looks very complicated when you have a different base other than 10 and e. So we try to stay away from other bases other than base e and 10. So we stay with common logarithm and natural logarithm. You got log base 1 over 2 and 6. So this will be the same thing as log of 6 over log of 1 over 2, or same thing as log of natural log of 6 over natural log of 1 over 2. Again, this is the same thing as, we could use any base. So like we could say the log of base 2 of 6 over log of base 2 of 1 over 2. But we try to stay with natural log or common logarithm whenever we change base.